Okay, problem 7.76. It says there's no energy stored in the capacitor in the circuit when switch 1 closes at t equals 0. Um, and switch 2 closes 10 microseconds later. Find V naught t for t greater or equal than 0. So what you want to do, you want to go ahead, I'm going to go ahead and redraw the circuit for 0 to 10 microseconds, right? So I'm going to make this prettier. Okay. So then we're going to go ahead and analyze the circuit. You know the drill. We do our ground node here. And this is going to be our V naught. And I'm going to say it doesn't really matter the direction. So I'm going to say call this I1 and then call this I2, right? We know this is direction and then we know this is V naught as well. Okay, so we do the KCL. We know that I1 equals 5 times 10 to the negative 3 milliamps plus I2. Equation for components. We know that I1 equals negative V naught over 4,000. And then I2 equals 20 times 10 to the negative 9. Or sorry, V naught, or no. Sorry. Yeah. So yeah, I2 equals dV naught t over dt. Okay. So these are our equations. So we can go ahead and plug this back into our KCL. So negative V naught over 4,000 is equal to 5. I'm just going to say milliamps, just to simplify. 20 nanofarad dV naught t over dt. Okay. So then move this here. We got negative 5 milliamps equals V naught over 4,000 plus 20 nanofarad. We divide everything by 20 nanofarad. So maybe we get negative, yeah, do this, negative 250,000 equals to 4,000 divided by 20 nanofarad. All right. Or no, 4,000 times 20 e to the negative. So this is yeah, 8 e to negative 5 plus dv naught t over dt. So from this, we're able to calculate tau, which is 8e to negative 5, or 8 times 10 to the negative 5. And k is going to be negative 250,000. So with this, these values, we're able to find v naught at infinity, which would be 8e to negative 5 times negative 250,000. So our v naught would be, v naught infinity would be negative 20 volts. Okay. And we'll have that, and our v naught times 0 would be 0 volts, because there is no energy stored in the capacitor before the switch turns. So with this, we can go ahead and formulate our equation, our v naught equation, for 0 to 10 microseconds. So go ahead and say negative 20 plus 0 minus plus 20, so negative, negative, positive, negative t over time constant is e to negative 5, so negative 20 plus 20 e negative, what's 1 over 8 to negative? Okay. So this equation here would be for t from 0 to 10 microseconds, right? So then we continue to our next part, where we make a circuit for 10 microseconds to infinity. So our circuit would look like this. Actually, we can just go ahead and use, you can just connect these. And we can do our circuit analysis. You know the drill. We make our bottom node ground. This is 30. Okay. And so we go ahead, we're gonna call this so I did it here. So I1, I2, I3. Okay, so we have KCL. We got I1 equals 5 milliamps plus I2 plus I3. Our equation for components. I1 equals negative V naught over 4,000. I2 2 equals 20 e to the negative 9 dv not dt. I3 is equal to v naught minus 30 over 16,000. And yeah. So then we gotta find variables are I1, I2, I3, V naught. And we got 4 equations. Okay. Right. So I'm just gonna plug this into Maxima. Now that it gets a bit more, there's more math involved, and this pen isn't the best to do the math. Plus I2 plus okay. So then go ahead and copy and paste these answers here. So now what we can do is plug in these equations. So, well, we want to look at this V naught here. Play with that. So V naught equals negative S, and well, yeah. So our S that we put in Maxima would be our dV, not T over dt. So I can go ahead and say 15,625 not equals negative dV t. Okay. Six, 0. So my tau would be 1 over 1,565. K would be 15. Okay. So this, knowing this, we can find our V naught at infinity, just tau times K. Plug these in, you get 10, right? Yeah, we get 10, and then with, let's see, okay. With the way this is put, I believe, so correction, something I noticed here, this would be negative. It's one thing I need to, so it'd be negative 10 volts here. The way it's put here maximum, this can throw you off. So this is negative 10 volts, right? And V naught at 10 microseconds. We can calculate this with this equation right here. So 20 minus 20 e to the negative 2, 5, 10 to negative 6. So you can use our equation for the time before, the time interval before, to calculate V naught at 10 microseconds. I'm going to plug this into a calculator, 20 to negative 6. It's going to be, oops, forgot the negative here again. It's going to be negative 2.350061948, but we can just round it off to negative 2.35 volts. Okay, let's keep going. So once we do this, then our V naught T for 10 microseconds T to infinity would be infinity would be negative 10 plus negative 2.35 plus or minus and okay, so um 10 minus 5 7.65 e to the negative, so 6.4 e to negative 5 t. Yeah. So there's two different equations, or yeah, different equations for finding V naught for t greater than 0. So for our first interval, we would get negative 20 plus 20. I'm going to highlight it here. And for our second interval, from 10 microseconds then to infinity, it would look like this. Okay, and this would be our answer to our problem.